So in our last class, we talk about writing a set of numbers between any two real numbers. We use a interval notation. Okay, we can use a interval notation or set notation or graph to represent every number between any two real numbers. Okay, now here we have an example. So let's go ahead and do these examples. So here we have to graph each of following intervals on the number line and write using set builder notation. So we have to graph each of these interval notation, and we are graphing on a number line. So let's start by drawing a number line. So this is our number line. In the center we have 0, right? On the right of 0 we have a positive number, on the left of 0 we have a negative number, on the right end we have a positive infinity, on the left end we have a negative infinity, right? So now let's locate negative 2 and 3. So negative 2 is it's negative number, so it should be on the left of 0. So let's say this is negative 2, and we have a 3 on the right of 0. Now the next, now what do we have with negative 2? We have a parenthesis. Now what does it mean? We are excluding negative 2, right? And how do we represent that? By using a open circle at negative 2. So we have a parenthesis at negative 2, so we use open circle. Okay, along with 3 we have a bracket, so it means we are including 3 in our set, and we represent that by using a closed circle. So this is our closed circle. Now, what part do we need to say? So this is an interval notation, and it consists of every number greater than negative 2 and less than or equals to 3. So what part in this number line is our set? So everything from negative 2 to positive 3. Okay, so this is a graph for our interval. Do you have any question? Now next, let's write down this interval notation in a set builder form. For that, we have a x to represent a number in the set such that our x is greater than negative 2 and less than equals to positive 3. Okay, so we have a parenthesis here, so we use strictly greater than sign. We have a bracket here, so we have less than equals to. So if you have a bracket, make sure to have equals to sign with an inequality. Okay, now for part B, so let's start with a number line. So we have a number line, negative infinity on the left, positive infinity on the right, 0 at the center. Now let's locate 4. So 4 is here. So with 4 we have a bracket, it means we are including 4. We have a closed circle. Now where do we find this number? The number which is less than positive 4. Do we find on the right of positive 4 or left of positive 4? Left of positive 4, right? So every number on the left of positive 4 including 4. So this is our graph, and in the set builder form, so we have x such that our x is less than, we have a closed circle here, so equals to positive 4. So every number which is less than or equals to 4 is in this set. Any question? Yes.
So just confirm, you apply like a open circle to.
Now for the infinity, okay, now here, so infinity, this is not a number. Okay, this is just representation for a very small number. Okay, we don't know what number is that. So we do not use open circle with infinity, whether it's positive or negative. Okay, so with positive 4, we have a bracket, means we are including positive 4. So we have closed circle at 4. It tells that we are including 4 in our set. Okay, but infinity, negative infinity, these are not a number. These are just a representation. Okay, these are a symbol to represent a very big number or a very small number. Okay, Okay, the next here we have a graph and we need to write an interval. So we have a graph here, number line here. So we need to write an interval for this red shaded part. Okay, so this is the shaded part here. Okay, so we have to write an interval for this. Now we always start from left to right. Okay, so what is the starting point here for the graph? So the graph is starting from -3. Do you agree? You are focusing on the red one. Okay, that is the shaded region. And at -3, do we have a closed circle or open circle? Close. It means, are we using parenthesis or bracket? Okay, so we have a bracket here, comma, then it's ending, terminating at 2, and at 2 there is an open circle, parenthesis. Okay, so this is the interval notation for this graph. Okay, next here, does anyone have any question for these two examples? Okay, so here we have to find the indicated set and a graph. So here we have a two set. So 1, 4 and 2, 5. We have these two set and we have to find the union of these two set. And we will use a number line. Okay, it really helps us to find the union here. So let's draw a number line. So we have a negative infinity on the left, positive infinity on the right. Okay, so let's say we have 0 at the center. So we need 1, 4. So let's make a graph for this set. So 1 is here, 4 is here. At 1 and 4 we have a open circle, right? So we have an open circle at 1, open circle at 4. Now what part of a number line do we set here for this set? So we have a parenthesis at 1 and 4, so we have an open circle. Now which part do we set? Do we set this part on the left, middle part, or the part on the right? It's the middle, right? So this 1, 4, it includes the every number which is greater than 4, sorry, greater than 1 and less than 4. So that middle region is our first set. Now in the similar way, let's graph our next set. So we have this one. So 2, 5. So 2 is here, 5 is here. Okay. At 2 and 5, we have a bracket. So we are using a closed circle. So we have a closed circle at 2 and closed circle at 5. Now, so what part do we set? So this set includes every number which is greater than equals to 2 and less than equals to 5. And that is from 2 to 5. So this is our second set. Okay. Now what will be the union of these two sets? Finding the union means we are making a list of every number from this set as well as this set, and we are writing without repeating. Okay. Now here on the graph, so we have to include yellow region as well as green region. Now how do you write an interval for both that region, including yellow as well as green? So from where the graph is starting, so we are trying to write an interval for this yellow region and a green region. Okay, so what is the starting point? From what number the graph is starting? 1. Okay. Now do we have an open circle or a closed circle at 1? Open, so parenthesis. And where the graph is ending? The graph is ending at 5. And at 5 we have a closed circle, means we are using a bracket. And this set is a union of the given two set. So if you are finding the union or intersection of an interval, you always use a graph. Okay, it really helps us. Okay, any question? Now let's go to part B. So we use a number line. We have a negative infinity, positive infinity. So we have 0 here, Oh, it's the same set. So 1 is here, 4 is here, right? So with 1, we have a parenthesis, so open circle. At 4, parenthesis means open circle. And let's set first set. So every number from 1 to 4 is this first set. Now let's draw our next set. So for this set, we need a 2, 5 is here. So with 2, there is a bracket. It means we are including 2 and we are including 5. Now let's set this graph. Okay. Let me use a different color here. So let me use this one. Okay. Our target is finding the intersection of these two sets. Okay. So this red graph is our first set. Okay. Green graph is our second set. Now, what is the common portion? So what is the common graph here? The black graph, right? The black colored portion is our common. And where that graph is starting, the graph is starting from 2. It's not 1. It's so we are trying. Okay, so the first set is the red graph. From 1 to 4 is first set. Second set is from 2 to 5, green color. Okay, and we need to find the intersection. Means we are looking for the common reason. Okay, we need to find the common numbers. And the common is, you see this, the black color, so this is a common. Okay, so we have a red first set, green second set, and the common is a green color, sorry, black color. And this is starting from 2, and we have a closed circle at 2, so it's including 2. And where it is ending, it's ending at 4. And at 4 there is an open circle, so parenthesis. And this set is the intersection of given two set. Okay, this is about finding the union and intersection of intervals. Okay, now the next we have absolute value. Okay, and this absolute value is the distance of a number from origin to a real number. So here what I mean, so for example, so we have a number line here. Okay, so we have a 0. And if you are asked to find an absolute value of any number, it means we are trying to find a distance of that number from 0, from origin. So if you are asked to find absolute value of 5, what it means? We are trying to find a distance of number 5 from 0. And what is that distance of a 5 from 0 on a number line? That is 5, right? So absolute value of 5 is 5. In the similar way, if you are asked to find the absolute value of 9, what does it mean? We want to find the distance of negative 9 from 0 on a number line. And what will be that distance of negative 9 on a number line from 0? It will be? Is it positive 9? Okay, so negative 9 is somewhere here, right? Now, how far is negative 9 from 0? That is the absolute value of negative 9. And how far it is? 9, right? So we are trying to find the distance. And distance is always measured with positive number. It's never negative, okay? So absolute value of negative 9 is positive. So finding absolute value means we are finding the distance of that number from 0 on a number line, okay? So in general, so we define the absolute value of x, okay? So absolute value of x is positive x if our x is greater than or equals to 0, and absolute value of x is equals to negative x if x is less than 0. Now let me take an example here. So for example, let me take this absolute value of 5. So we have absolute value of 5. Now, if you compare absolute value of 5 and absolute value of x, what is the value of x? So you are comparing absolute value of x with absolute value of 5. So what number do you see in place of x? We have 5, right? Now, is that 5 greater than 0, right? So 5 is greater than 0, so the absolute value of 5 will be same as x. Our x is 5, so 5. Okay, now if we have absolute value of negative 9, our x is negative 9. Okay, x is negative 9 means negative 9 is less than 0, and the absolute value of negative 9 will be negative of x. So our x is negative 9, so negative of x, and we end up getting positive 9. Okay, so this is how we calculate positive 9 here. The absolute value, that is the distance, and we measure distance with a positive number, so it always has to be a positive numbers. Okay, so we have here examples. It should be very simple for you all. So what is absolute value of negative 3? It is positive 3, right? So for B we have negative 4. Now let's find the absolute value of 4.5, and what is that? 4.5. So this is negative 9.5. So here, okay, now let's simplify inside the absolute value. So negative 4 plus 5, that is, sorry, negative 4 plus 9, that is positive 5 plus 3. And absolute value of 5 is 5 plus 3, which is 8. And there are the basic properties of absolute value. So absolute value of any number, any real number is always greater than or equals to 0. Okay, so if you find the absolute value of any real number, it has to be 0 or has to be greater than 0. Okay, and because absolute value is the measure of distance, distance is always positive. Okay, and for that reason our absolute value of a or absolute value of any real number is equals to or greater than 0. Next, so if you find, so absolute value of positive 5 and absolute value of negative 5, how these two are related? They are exactly same, right? So that's what we have for part B. So absolute value of negative a is same as absolute value of positive a. So these two are equals to each other. Okay, so the next property, so if we have absolute value of product of two number, let's say absolute value of 2 times 3, okay, so we can distribute absolute value. So this is same as absolute value of 2 times absolute value of 3. We can simplify and check. So this is absolute value of 2 times 3, that is 6, equals to absolute value of 2 is 2, absolute value of 3 is 3. Absolute value of 6 is 6, equals to 2 times 3 is 6. Okay, so if you have a absolute value of a product of any two numbers, then you can write that as a product of two absolute value number. Okay, so here we have absolute value of product of two number, a and b are any two real numbers, and the absolute value of two product of two number is equals to product of two absolute value number. In the similar way, if we have absolute value of quotient, so let's say we have absolute value of 4/9, okay, this is same as absolute value of 4 divided by absolute value of 9, and we can check that. So what is absolute value of 4/9? It is 4/9, right? Equals to, what is absolute value of 4? It is 4. What is absolute value of 9? It is 9. And these two numbers are exactly same. Okay, so these are the properties of absolute value. Okay, do you have any question? Okay, the next, we use this concept to find the distance between any 2 points on a number line. Okay, so here let's say our a and b are any 2 points on the number line, then the distance between a and b is given by absolute value of difference of those two numbers. Okay, for example, if you are asked to find the distance between negative 10 and positive 2. What will be that distance? Okay, I hear 8. So we want to find the distance from negative 10 to positive 2. Will it be 8 or 12, right? So what will be the distance between 2.5 and 7.8? So now we have a method here. So to find the distance between any two real number, so what we do, we take the absolute value of difference of those two numbers. Okay, so we had 2.5, difference of 2.5, and what number did I say the next one? 7.8. Okay, so you just find the difference. So you find the absolute value of difference. Make sure you have the absolute value. Okay, so you have the absolute value of the difference. Okay, so this is absolute value. So 2.5 minus 7.8, that is negative 5.3. And what is the different absolute value of negative 5.3? It is positive 5.3. So if you are asked to find the distance of any two number on a number line, you find the absolute value of a difference of those two numbers. Okay, you have to find the absolute value of a difference of those two numbers. Okay, so here we have an example. We are asked to find distance between negative 6 and positive 4. So we write down the absolute value sign. Okay, then difference of these two numbers. Difference means you have the subtraction sign. So negative 6 minus 4. So this is absolute value of negative 10 and this is positive 10 is the distance between these two numbers. You find the difference and find the absolute value of that difference of two numbers. Okay, that is the distance between two numbers. Okay, the next here, order of operation. We all know how to simplify this expression, right? So let's go ahead and do the examples here. So what would be the first thing that we have to do for part A? We simplify the exponents. Okay, so we have 3 square. So let's simplify 3 square. And what is that 3 square? Okay, so 3 square is, we are multiplying 3 2 times. Okay, so this is not 3 times 2. So you are multiplying 3 and 3. So 9. Then we write the remaining as it is. Okay, then we solve. So what will be the next one? Which one do we solve? Parenthesis, right? So we have 9 plus 2. So inside the parenthesis, negative 3 plus 7, that is positive 4. Okay, so we are simplifying in order. Okay, then what will be the next one? Do we add or do we simplify this? So we simplify this, right? So this is 2 times 4. So 2 times 4 is 8 and we have 17. Okay, now for B, always start with exponent. Okay, so you always simplify your exponent first, then parentheses, okay, then multiplication, division, then addition, subtraction. So 3 square is 9 plus 1, 4 minus 7. Then we simplify our numerator, denominator. So 9 plus 1, 10, 4 minus 7, negative 3. Okay, this is our final answer. Okay, for C, we have an exponent here. So let's simplify this. So we have 6 plus 3 times 5 minus. So what is the square? Okay, oh, this is not this. Okay, so we have a parenthesis and negative 3 square is 9 plus 2. Okay, now what will be our next step? Which one are we solving? The innermost parenthesis, right? Negative 9 plus 2. So let's simplify this one. 6 plus 3 times 5 minus negative 9 plus 2 is negative 7. And we have a parenthesis. So 6 plus 3. So we have 5. Negative times negative 7 is positive 7. Then we still have parentheses. So let's simplify that. 6 plus 3, 5 plus 7, 12. So this is 6 plus, now you multiply 3 and 12, 36, and this is 42 is our final answer. Yes.
Since we're squaring a negative, wouldn't it be positive 9?
Okay, now let's find out. So we have negative 3 square. Next, if you have negative 3 parenthesis square. Now what's the difference between these two numbers here? So in the first expression, we have a square for 3. Okay, there is no square for negative sign. Now here, we have a parenthesis 3 and we have a square. Okay, it means this square is for negative as well as 3. Okay, in our case, we don't have a square for negative. That square is only for 3. Okay, so negative remains as it is. Okay, negative remains as it is. 3 square is 9. Now, how do we simplify? Okay, so here, so this square is for only 3. So negative remains as it is. 3 square is 9. Now, in the second expression, so this square, since we have a parenthesis, okay, this square is for negative as well as 3. What is the square of negative? Negative times negative is positive, right? So we have a positive, and 3 square is 9. So if you do not have parenthesis, then that square is only for number. Okay. Okay, so this is all about our section R.1.